Hello, welcome to this Saturday stream. Wait, it's not Saturday. What day is it? It's Monday. I haven't caught up on sleep, so I didn't stream for like 5 days because I had family over, and I was kind of hoping to get a lot of sleep, and I didn't at all. So yeah, still really tired. So I kind of got to work on that because sleep is super important if you're programming and thinking a lot. But you know what? Whatever. So we're gonna do something easier, something that I just kind of like to do this morning, and that's ray tracing. I made a ray tracer the other day. One second, let me post this in chat. A Monte Carlo ray tracer that supports volumetrics, chromatic refraction. It did a whole bunch of stuff that I didn't combine into one before. I never actually have made a path tracer that supports. I've made a path tracer that has volumetrics separately and a path tracer that has um, like regular materials separately, but I've never combined volumetrics and a normal ray tracer. So this is the scene. It's a pretty efficient ray tracer. It's interactive, so you can look around, use the mouse. So the one thing I have never done before in this ray tracer was the chromatic refraction right here, where each color has a separate refractive index. I think that's really cool. But you can see the volumetric right here. If I go like halfway, basically if I go like inside the cloud, you can kind of see how it's a volume. Over time, these points add up to be clouds. It's kind of like a painting if you think about it. Man, every time I don't stream for like 5 days, I go and I think all my stuff on OBS gets messed up, but it doesn't. But you can see it looks like clouds. It's a volume. It's not as good of a volume as you could do if you can see when you go inside of it. It's pretty dark. That's because there's not a lot of bounces, and volumes require tons of bounces on the inside, and yeah. But anyways, what I'm going to do today is I'm going to make another procedural scene. It's really pixelated. Can you write something to clean that up? No, that's noise. That's Monte Carlo path tracing. So it's yeah, Monte Carlo path tracing is noisy. It's basically just trying all the different methods. The only way to fix it up is just to let it sit there for a long time and wait for what's called convergence, where the noise basically adds up and sums up to be the correct result. But it's subject to what's it called? Something over time. Basically, it slows down over time. Right at the beginning, it handles the largest values, and then over time, it converges the lower values. It's so basically like as we get longer along here, it'll take longer to fill in the details because it's filling in smaller details. It's complicated stuff. There's like stuff you can try to do to improve it, like this Martin Roberts R2 point sampling that I implemented that makes it different. It makes it you can see there it's all noise when it starts, but here you can see it's going in splotches. And it's supposed to be more even, but it's really hard for me to tell the difference because it's so noisy. Sometimes I actually think that the regular Monte Carlo sampling is just white noise sampling is better, but I don't know. Anyways, there's a few things I want to fix up with this. This is the main ray tracing code. These are a bunch of helper functions like ray marking. Basically got macros to do ray marking for you. This is the volumetric and chromatic refraction. Here's the normal ray tracing. You've got ray versus plane, ray versus box, ray versus sphere. Rotation, which rotates your ray position and direction. And then this is the volumetric cloud distance function that's ray marked. You can see here. So that uses the ray mark macro from before. Use that volume macro up there. The volume distortion is just a bunch of cosine waves. How are you going to use it for a proper application if it's pixelated? It's not supposed to be for a proper application. It's just supposed to be for like a rendering. And like my top shader on here is noisy just like it. It's not supposed to be used for like a proper application. Ray tracing is slow as heck. This is also running on like a GTX 1050 and like I don't think it'll even, if you look at the FPS quickly, it runs at 17 FPS on full screen. Like ray tracing is so goddamn slow. And this is using like ray versus plane code, which is very, very fast. Triangles are even slower than this. It's not supposed to be for like an actual application. It's more just something to play with. Actually, for my whole stream, the past like failed. No, I just typed in the wrong URL. For like the past 2 weeks, actually like a month, on stream I was working on this ray traced game. It's a ray traced marble game. It's a good looking course. Scaffold fractal is pretty good looking. But this is a ray traced game. It is still noisy because it's ray traced. And it's a terrible course because the marbles get stuck all the time. But yeah, that's just ray tracing, as it sends out rays randomly to get the correct result. And yeah, because it sends them out randomly, it's noisy. It's just the flaw with ray tracing. But yeah, that just made... Okay, I kind of thought I would have dropped frames there. Like, that's the other thing with ray tracing, is it literally uses 100% of my GPU, and then if OBS doesn't have any power for the GPU to do the rendering, it drops frames. So that's the other thing I gotta watch out for. Alright, got some music. Alright, so the first little optimization that I want to do right here is when I do the culling for the ray tracing with the sphere bounds, like basic frustum culling and nearest culling, I also want to do farthest far away culling. Basically, if this value from the ray tracing, after ray tracing, you're supposed to depixel / smooth the frame. Yeah, you can't do that with transparent rendering. You need like motion vectors and you need like depth information, and when you're doing transparent rendering like this prism, the only type of thing you can do is like a Gaussian blur across the whole screen, because you have no depth information or anything to work with about keeping sharp corners. Like, the other thing is, actually, it's here. This is a real-time path tracer I made for Unity. You can see it has denoising. It has smoothing, and that's because I had depth information and I was able to tell the different materials. But that smoothing also comes at the cost of making things way less sharp. Like, if you're smoothing that out and basically blurring it to reduce the noise, you're also losing all of the sharp features in the reflections and everything. So that's why if you're doing an actual long-term rendering, you don't want any denoising or anything that's going to actually mess up the end result and make things blurred where they would normally be sharp. And then there's the whole other thing, is if you're just applying a low pass to the screen, you're basically just doing the same as rendering at a lower resolution. Because you're reducing the pixel density. It's complicated, man. Anyways, I need to store this value from the ray tracing result. Why not online smooth non-transparent objects? I've never heard of online smoothing. Is that only smooth non-transparent objects? Because that would require rendering to depth and having some difference between non-transparent objects. And the noisiest parts of this scene are the caustics and the volumetrics, because that requires the most bounces. And that denoising would do nothing to help it. So like, oh yeah, here's the other thing. There's a thing called importance sampling that I have implemented here. It makes the non-transparent objects, oh, I gotta fix that up first before I run it. It makes non-transparent objects way less noisy. So you can see here, oh wait, that's too little. See here, way less noisy for the walls, but the volumetrics and caustics here are still super noisy. And that's because, like, there's literally no way to do them except for sampling. Like, you can't smooth them out without losing sharp edges. And you can kind of see the importance sampling still isn't perfect. It actually causes the caustic refraction to mess up a little bit. So that's why I don't even set that high. But yeah, there's other methods for making it less noisy besides denoising. Personally, I'm not a fan of denoising. Why not add material system with the ray tracing? That's what this is. The metallic roughness, specular, opacity, refraction index. That's all a material system. It's like this prism is the thing with the different refractive indexes. You can see the colors separating. This is a diffuse wall. This is a glossy wall. You can see that everything's blurred in it. But yeah, it's all based off randomness, so it's noisy. That's interesting. What's right there? Why is that really bright point building up there? Is that a bug or... Sometimes I feel like this R2 point... Oh no, it's not the R2 point sampling. I'm confused. Oh, it's the light reflecting off there. That's so interesting. You can see the light from right there reflecting off the floor. That really bright area right there. Huh. I wonder if that's correct. One sec, let me test something. That actually might be a bug. Oh no, I think that might be a bug. Oof. Why not do smooth then sharpen the edges? Because that loses data. Oh my god. Oh my god, I had a bug in this. Oh no. I wonder how this changed how it looked. Or blend a rasterized render over top because it's in Shadertoy where you can't do rasterizing. It's all in shaders. God damn, I can't believe that was wrong. Well, actually I can. It makes complete sense. It was causing the ray. I don't know why so many parts of the ray were going back into the surface though. Wait. Bract sign. I don't know, actually. Let me compare the two. Shaders can rasterize, not efficiently. Alright, so that's 10 seconds with this off. Let's try 10 seconds with it on. See if it's less noisy. Yeah, so that actually looks less noisy, but has this here, is that, it's worth a try. Have you made a rasterizing shader in just fragment shaders before? Yes. Do you have a link to it? And does it use just fragment shaders and not any compute or vertex shaders? I also need to let it point the camera straight down. Right now I'm limiting it. Do it 2% off. Alright, what am I going to do here? Am I going to settle for the more noisy but correct? It's been a while, but I did do this before GitHub. Rasterize. Using rasterization method to render polygonal mesh. Oh, it's not made to perform, damn. Oh god, yeah, so it has to loop over every triangle. Oof. That's like literally the same thing as ray tracing. This is actually slower than ray tracing. Oh my god. So that's 128 triangles there. This is 800 triangles. And this is ray tracing them. Yeah, so it's actually faster to ray trace when you're just in fragment shaders. Man, this is really difficult. I actually don't know what to choose here. There's the less noisy version that's incorrect. It's got this giant freaking thing on the floor because it's got bias for the ray. That's the thing I kind of don't understand. Do you have access to the geometry of the vertex shaders? It's all procedural. So the geometry is like the actual cubes and triangle prisms and the shapes. Let's see what this looks like without the sign dot. So that's a lot more equal. You know what? I actually think it's normal to bounce off the floor. So, you know what? If you think about it, diffuse objects will have internal bouncing. So, I don't know if you would call it internal bouncing, but self-bouncing. It's alright. Maybe I should add a toggle for the diffuse roughness, but I guess you could do that with the metallic argument. Alright, let's add another part to this culling here. So since I'm also checking if the ray is closer than the current hit, works in 3 stages: vertex shader, frag shader, geometric shader. Geometry shader comes before vertex shader. It generates the geometry, then it renders it first step with the vertex shader, then it renders it the second step with the fragment shader. Alright, so we got our bounding trace distance. So if that bounding distance is smaller than the current hit, which means it could be closer. And I guess I also need to check and bound distance smaller than view distance. That should give a little optimization. I forgot. RP, undeclared identifier. What? Oh. No, that's false. Before vertex shader. Unless I'm understanding nothing. Geometry shaders reside between the vertex shader and the vertex post-processing. Okay. So yeah, you're right. It's actually in between the fragment and the vertex. A single primitive is input and may output 0 or more primitives. Their implementation defined. Take one primitive and rendering it to multiple images without having to change bound render targets. Yeah, so I guess you do vertex shader processing in the geometry shader. Geometry shaders take a primitive as input. The outputs or tessellation stage are thus fed to the geometry shader as arrays of variables. These can be organized as individual variables or as part of an interface block. Can output as many vertices as they wish. To provide this, output values in vertex shaders are not arrays, instead a function-based interface, emit vertex. Yeah, I've actually never used geometry shaders in OpenGL. I only used compute shaders. So it's interesting. That's weird that they put it after the vertex shader, because like I would think that you would want to use the same vertex shader processing for all of the, like you may need to do vertex shader processing on the next geometry that you're outputting from the geometry shader. I don't know. But alright. This appears to work. Let me see if things disappear. If I add a little -1 point, do these things disappear? Yeah, they do. Awesome. Alright, so that's a little bit of an optimization on the renderer. And I feel stupid that I had that part before that messed up the rendering, but Alright, save that. So one of the other things I like to do is I like to just go through the latest shaders. We're going to look at some of these. Red, green, blue to spectral mapping. Wanted to see if we could learn the inverse of the C color matching functions with a neural network, doing this for albedo so all values are normalized to 0 and 1. Decided to see if we could learn neural network. Here's a breakdown. Sorry man, I don't allow links. If you have like a name of it that I can search though. Error term in the top left, numerical value bottom left, color ramp on the left, middle reconstruction histogram. Seems to be matching it perfectly. Input wavelength in nanometers. This is pretty awesome. Let's break down. All right. Oh yeah, Twitch chat doesn't have what's the video called? I can just type in the video on YouTube. Now, network use, deep feed decoder. So, RLU. Optimizer. Atom. Oh, interesting. Ooh, there's a lot of weights though. It's a pretty big neural network. Just for decoding and encoding some color. Still cool though. Why did this go up to HD quality? God damn it. Trying to make endless spirals made of fog. This is cool. Thin matrix geometry shader. Which one? He has like 3 videos on geometry shaders. Is one of these on rasterization or? Ooh, there's a fractal one over there. Curlies. Oh, this is another one of that. This one isn't as cool. Molten fractal. Oh, I love these Raymark effects where they illuminate the edges with the number of steps. It does look like a molten thing. Something. Molten something. Number 49.
Hello everyone and welcome to this week's OpenGL 3D game tutorial, and this week we're going to be having a look at the basics of the geometry shader. So before we have a look at the geometry shader, let's just quickly recap what our shader pipeline looks like at the moment. So let's say that we want to render a simple cube. The first stage of the pipeline is the vertex shader, which takes in each vertex of the model and it processes them individually. The vertex shader gets its input data for each vertex from the VAO, and it outputs the vertex with various user-defined values that actually assemble. So the fragment shader are the interpolated per vertex variables, and the rendering a load of lines, it would execute once for each line, and if we were rendering points, it would execute once for each point. The input to the geometry shader, therefore, is the entire primitive that it's
It explains what the shader does to detail. You mean, so it's not on rasterizing? Damn. I was just reading the Wikipedia article on, or the Chronos article on the geometry shaders like 10 minutes ago. This is just another. Ooh, whale sequence. Low discrepancy sampling using the whale sequence. Ooh. Ooh. By Herman Way. Sequence of all multiples of a rational A. It's distributed modulo 1. Oh, it's very simple, similar to the Martin Roberts R2. Two and times that divided by exponent 24. That's an interesting algorithm. Oh my god, it's slow though. Oh god. That's just because Fabrice is just looping through everything. That's great. Not trying to be fast at all. Oh, I love DR2's roller coasters. This is gonna be good. Oh my god, it's not very fast. Oh god, it's so slow. It's so slow. Okay. And that could have been bad. Pretty cool though. The trains don't look real when they're sliding along the tracks there. Oh my god. There's no comments. Well, still really cool. Smooth Julia set. Seen this before. Mandelbrot set. 3D animation. Where is it? I feel like I'm gonna get debated. Or it's gonna explode. Yeah, here we go. Not the best. Sparse voxel octree ray tracing. Oh my god, really? I bet this is going to be super slow. Oh my god, 8 FPS, Jesus Christ. Holy shit, they just put all the voxels in a constant array. Oh my god. Oh god. They're using up so much memory, this is not going to be threaded at all. Are you able to access the vertex and geometry shader? Not on Shadertoy. It's just fragment shaders. 2 triangle fragment shaders. Well, stack between 0. Stack position plus plus. Yep, that's just brute force voxel octree ray tracing. Oh my god. Oof. Oh god. I like this one. Look at his little eye. I already like this one. Flash of rainbow. Oh. Simple spheres. Just playing around with 3D spheres, reflections, soft shadows. Not bad. I've already seen these ones. Alright. That was cool. Alright, let's make a procedural scene now. I copy this code over as a template. I'm gonna try and make like a deserted apocalyptic, I don't know if it's like a desert, basically like a big barren plain of dirt with some buildings knocked over in it. Just something really simple, because I haven't done a lot of procedural modeling lately, so it's something to get me back into it. So of course, to start off, I'm just going to start with the flat plane of dirt. So we're going to erase all this stuff here, except for the plane floor. That's going to be the ground. And I think I'm going to use a cube map background to begin, to give it some light. I guess I'll do the forest. And I don't want mapping. So to do that, go to the ray background, sample the cube map texture like this with the ray direction. Oh yeah, and then I got to apply gamma correct because of the way the ray tracing works in linear space. Alright, so here we go. Now we got Wait a minute. Does this still have distortions on it? Or is it biased? Let me check this. Is it the R2 sampling? No, it's not the R2 sampling. Alright, I gotta make sure this is perfect because I am obsessive. So my issue is, it's kind of hard to see, but you can kind of see the outlines of everything of the background here. And there shouldn't be the outlines here. Those subtle gray lines. Unless this is like not all diffuse and I messed something up. But it seems like it is all diffuse, so oh my god, I'm an idiot. It's the light importance sampling. Derp. Derp, derp, derp. Derp. So the light importance sampling here, it checks whether or not it actually hit a light. So what I need to do here is I also need to check on the background if important. Or if not important, then add the background, because that's the issue here, is it's adding the background from the importance sampled ray, which is sent in one direction, so it ends up illuminating one direction of the background. So that should fix it. Yeah, there we go. Awesome. Okay. And you know what? I should fix that in the template too. Just replace that last line. Another thing I gotta do in this one is increase the view distance. It's gonna be a pretty big scene. Oh, the one thing I dislike about Shadertoy is that it doesn't let you choose your preview images. It just does it every time you save. So if it's like, basically if I just want to save it quickly like this, it's gonna save it as a really noisy image. Alright, so I'm going to increase the view distance here to like, do like 100. I'm going to do 3 bounces because it's such a higher view distance, and we're mostly going to be doing opaque objects. Oh man, that R2 sampling really does not look good when you're moving around. Like, it's actually worse than the noise. It looks like, oh, that bright flashing like that is brutal. It's actually better with the noise. Alright, so first thing we're going to do is we're going to make dirt, or try to make dirt. Procedural dirt. So I'm going to start it off as just a diffuse material. Completely opaque. And yeah, completely diffuse, not metallic at all. Alright, then I need the color of dirt. Are you fucking kidding me? Dirt ground image. What has the world come to that you don't get pictures of dirt when you search dirt on Google? So I'm thinking this is like the color of dirt that I'm looking for. So get the color, apply a blur, get the average color for an area. Now apply that color here, so that's 185, 120, and 94. Okay, so that should be the color of the dirt now. There we go. So now we need a little bit of bump or texture to it. So what I could do here is I could warp the normal, so I could make it bumpy, but it still needs some texture, so I think we're going to do texturing first. So I'm not sure how I want to do this, if I want to just try with some simple sine and cosine waves to begin, or maybe some Perlin noise. I feel like regular lerped noise would be better, but maybe I'll try adding the distortion first. I've actually never distorted the normals in this ray tracer, so let's see if it works. So I have to normalize it after distorting, but basically what I do is I add some distortion to the X, Y, and Z, or distortion to the X and Z. I guess I'll do this in 2 parts. Plus equals and then normalize it. Spelled normalized wrong though. Not very smart. Alright, I think that's good. Didn't really seem to do anything. Let me look at something. Oh, I gotta do RP plus RD times. Oh, okay. I forgot that I need to manually calculate this position. So this is the sample position for the ground texture and for the normal. Alright, it's really hard to see, but there's really subtle waves there. If you increase the frequency of this, it'll probably show it off more. Yeah, you can kind of see there's some subtle bumps. Maybe increase it even more. I'm actually impressed it's not showing more. I don't know. Maybe because the background doesn't have yeah, like I said, I've never distorted the normals. In this scene before, so it's hard to tell what's actually going wrong here. And do these comments even work? Is my noise function scuffed? Is that what it is? Oh my god. Ray tracing is hard. Yeah, so I think when you get close to the ground like this, you can definitely see that it has some distortion at the beginning, but that's okay. I gotta think about what's happening with this normal. So it checks if the ray hit the plane. This is the normal right here, is up. So then if it hits, it applies this sine wave distortion. But yeah, you still can't see. I wonder if it's just these environment maps that... One sec, let me try adding a custom background. Let me try just doing a light in the sky. That's just RD, direction of the light we want it to go. And then that'll be negative, so we actually need to do max 0. Alright. One too many or one too many? Okay. Now that's bright, one light direction. It's like, let me try doing one bounce. Yeah, so you can kind of see the normals right here. Huh. So I don't know if it's the lighting really. You can see the light reflecting off there. Maybe doing 0.2 instead. What if I just distorted it by... I just used one of these textures right here. Which one looks like dirt? Probably this wood one. See, now this is difficult because it only adds to one side. Actually, I don't know how I should distort the normal here. Should also turn off light importance sampling. Oh no, I forgot about this. Depth importance sampling. Oh, this is just supposed to be this. Okay. Alright, so I'm going to copy this over to the template now that I know it's fixed. Alright, I'm going to try the texture because this is not working. Alright, so I'm going to do plus equals pow2 minus 0.5 texture I channel 3 T position. Okay, I feel like something's actually messed up here because there's zero texturing here. Something must be wrong. Whoa. That texture does not look too bad. It's interesting though how the normal doesn't really seem to affect it. I'm wondering, I'm going to try making the background still sharper. When I make it sharper and smaller, I also need to brighten it up to compensate. Alright. There we go. So you can see the texturing. Now I need to somehow get the normals to match up with this. I'm going to try using a noise texture. I'm thinking there has to be something I'm missing about this normal here. Because, like, I know this is all based on the normal down here. So changing it should... This is so weird. It's only got one bounce. Yeah, which means that, like, doesn't make any sense that it's lighting up that much, even if it's sending in the other direction. This is repeating, right? Yeah, it's repeating, it's linear. Calculate upright, normal. Yeah, like, what the? Wait. Normalizing it fixes it? Oh my god. Oh my god, is this an angle bug? Is this an angle bug? Disable angle, true. No, it's not an angle bug. Alright. Wait. Actually, can't be sure. Might need to restart the browser. This angle's still turned off. Disable angle. Now, if this works, even with normalizing it. No, it's not an angle bug. Alright. So what is it then? Let's walk through this. So when this isn't normalized, it works. No, this is like times 10. Maybe if I do times 10,000. Oh my god, this is so weird. So what should be happening here is that because the normal is 1, let me look at this array plane code. Yeah, so because the normal is 1, it should be adding this to the x and z. So then if this is like 10,000 to the x, or 5,000 because it's minus 0.5, then this should normalize to being like 1. So it doesn't make sense why it only works when it's like this. That does not make any sense. Normalize h dot xyz. Okay, now what if I add this? I do plus. Still none. What is the normalize function doing here that's making it so weird? Just normal equals s, then execute m code. Right here, it executes afterwards. So weird. If I normalize here, I am actually completely confused what's happening here. RD times equals sine dot normal dot xyz RD. Let's try flipping this around again. Wait. So now it works. This is so confusing. Oh my god. Wait, so this works. But the other version doesn't. And it has this point on the floor. Is this correct? I think this is actually correct then. Maybe I had it correct the first time. Let me inspect this further. Oh man, this is really hard to figure out if it would actually look this way. So this is microscopic bumps causing a specular effect even on the diffuse surface right here. So what I'm thinking what should actually happen is it should just be like SR like this instead of reflecting off the surface like specular. Yes, so now that is diffuse. Now let's see if that gives the correct effect right here. Yeah, oh my god, okay. So I had this path tracer all messed up. All messed up. Okay, I gotta change around how this works. I'll be right back. I'm just gonna go and get some water. Alright, so now that I figured out that there's some major issues with this, I'm going to stop working on that next shader and I'm going to work on fixing this up. So I'm going to keep what I've got here. And I'm going to work on making it have actual diffuse reflection then. Because this is too rough to be diffuse. Like, I can't believe I'm actually saying that, but so somehow I need to separate these. So do like so I'll need to do this for both. But I could do this after the bounce. Break out here just because it won't matter. That'll actually mess up the background sampling. Oh. Alright, so if it's specular, then the ray direction. Oh my god, I still have this line of code that's stepping out if it hits the emissive. Ooh, I have a bunch of things I need to fix up here. You know what, I've been listening to this guy's music a bunch. It's just got a really good bass. I'm gonna listen to some of it. Houston is the problem is his YouTube. I think he has a SoundCloud too. It's got some really good game remixes. Alright, so for the specular, we're just gonna... actually, so this is the part where I need to do it differently if there's opacity. Opacity? Hey. That's Google. Opacity.
Opacity.
Opacity. I'm an idiot in the morning. So somehow I need to separate these. Actually, it would probably still be best to just do it down here, and then instead I output some value that's like cool, diffuse, if, diffuse, or actually I guess this is checking specular. Specular. Roughness equals 1. Back to bumps for translucency. So this is the part where I have to do it differently. For the opacity, it stays exactly the same. But for this, I need to do if diffuse, else reflect. Diffuse, then the next ray direction just equals that. Then we only want to do this importance sampling on the diffuse. So add that importance sampling right there. There we go. Should this be if metallic bigger than a random W? So yeah, I'm gonna switch this around. If specular, then ray direction is reflected off the random bump direction. Otherwise, let's see how this looks. Oh my god, that actually looks better. I feel like an idiot for not doing this before. Now I'm wondering, does this also make the volumetric look better because the lights are bouncing around in it better? Oh, it does. You can see the red reflecting off there. I'm so stupid. Why didn't I do this before? Jesus. Now I can actually lower the light brightness, I think. Like, that prism is actually too bright now that I look at it. What should I do about that? I guess I could lower the light brightness a little bit. Light emission down to 150, we'll try. Yeah, just that's better. Awesome. So happy to have that fixed up. Now should I go over to do the abandoned city? Yeah, you know what? I think I'm going to take this over to the next. Or is there something else I want to test? There's actually also a little neural network test I want to do. I feel stupid realizing now that this path tracer had huge errors with it the whole time. But I mean, that's the way it goes. I might do the neural net test. I don't know. Gotta think about what I want to make. Yeah, you know what? I think I'm gonna save that. I'm not gonna do that next path traced scene yet. Damn, I didn't even have mouse movements on these old shaders. And this just brute force with the lights on the ceiling. It looks cool with that infinite mirror though. This was actually a really nice scene. Should do something like that with the new path tracer. Something else I should do is another one of these per pixel particles. With actually better gravity or yeah, something like that. Well, I could always do a neural net test. There is something I've been wanting to test for a bit now. So I might do that. Just a feed forward neural net. It's trained on a constant function. Target's just going to be a sine wave. It's going to take a long time to train, but whatever. So it's going to be connected to the 3 things behind it, as well as a bias. I feel like biases are incorrect though. I might not do a bias at first. Take the noise function from here. Initialize the neural net with the noise. Neuron connection weights, W equals neuron state. Maybe I should compress the neuron weights. I could use this compression function here. Convert to Vec2 with decent formatting. This is slower but has better. So we'll do this, I think. Alright. Hold on. This is way too loud. One sec. Holy shit, he actually did an Undertale remix too. Close neuron connection weights. Maybe I should increase the number of connections. I don't know. Backward neuron. So how am I gonna compress these with the best format? I guess I should actually compress the state instead of the weights. And 0 state. Forward backward state. B to I. Alright, now we're going to display just this raw result here. For simplicity. How's the volume of this? Oh, it's still a bit loud, but it should be good. Alright, now that's interesting. This hash function seems like it has issues. Or something. Let me try something. Let me try using this noise function. Oh no! It's literally just a bad noise function. Oh god. I'm just going to output the same result here. Alright, so now it's initialized. What I'm going to do is input on probably the top, output on the bottom, or maybe input on the left, output on the right. And then I'm going to display the results here. Alright, so first I'm going to input, so if u.x smaller than 1, v2i, rec2, 0, target, u.x to u.y divided by I resolution.y. So actually I'm going to display, so if iMouse.w bigger than 0, then I'm going to display the neuron state. Display the backward and forward. Then I'm going to chart here the difference between the target and the neuron and the output neuron. So first we're going to graph the target. Then we'll get the neuron value. So I'm actually going to need to do some slope calculation to chart this correctly. Unless I want to interpolate it myself, which I don't. Yeah, I don't think I'm going to do proper charting, so instead what I'm going to do, sample the texture, on the right, and all the way down. The state is in X. Okay. So now we're going to graph it. And C plus equals max 1 minus absolute value TV minus Y times however sharp we want it to be, like that. Alright, so we've got a line now. So that's going to be green because that's our target. It's going to be blue. This is going to be what we want it to be. The neural net. Alright, now we need to propagate. Do our forward propagation. So I'm not going to do this in a for loop, I'm just going to hard code it. Texel fetch, I to B, texel fetch, channel 0, ivec2, dot x minus 1 and u dot y plus o dot w dot x times weight. Okay, so now forward propagation -1 n dot x n dot y n dot z. Then we encode the next state here, like that. Legal vector field selection. Oh, because W is the same name as that. Okay, this is interesting because it should be propagating values with the weights now. At least if it's initializing oh, this is supposed to just initialize u.y divided by iResolution.y. That would explain it. So there's our forward propagation. So eventually it's going to hit here and chart it. Alright, something's wrong there because when this state goes along, it should show up in the blue graph. NV equals I to V. Texture. It's clamped. I don't know. U.x divided by iResolution.x on the Y. I to V. So I know it's propagating along. For whatever reason, it's not reading it here. Maybe the 1 index is too far over or something. I don't know. U.x divided by iResolution.x. The sampling point. Maybe 0.99. Okay, something is definitely off here. Because this is sampling it. Normalized coordinates. I can see right here that it's outputting in the X. Oh. Maybe it's the interpolation. No. That's so weird. This is at 0.5. So it should be at this part right here, which we can see is all red. So now why isn't it graphing that? The only difference is it's texture instead of texel fetch. I do texel fetch. So now it works. This is ridiculous. And that chart is all over the place. Oh God. Okay. So what we want, first of all, is we want these to add up to be one. Yeah, like that, like roots. You can see how there's still areas that keep propagating there. It's basically completely random. Well, it is completely random, initialized. That looks good. So that still has some dark areas and it seems to be losing slight power. So now we need to train it with back propagation. So we have our forward propagation here. Going to make this macro do all propagation. Actually, no, this is just forward propagation, backward propagation. So I need to load in the error at a certain point. So if u.x equal to I resolution at x minus 1, source error. So we'll put the backward state on the blue, on the green. So then the initial backward state equals, let's actually do absolute value here now that I look at it. This will display. Okay, so it's the direction from the target minus the state ns. So now this is going to need to load. I'm going to do this with a for loop because this is going to need to load the other neuron states. So this will grab the state of a neuron one ahead. Yeah, so actually this is going to be another one that's going to be weird to do in a for loop. back propagation, BS plus equals neuron state. W equals I to V, ns dot W dot Y. Plus equals times the weight. Alright, so that should be -1 with an offset of -1. Then the weight is Z, I believe. That's Z. Then 0, it's Y. And 1, it's X. So I need a way of resetting the error, I believe. Or at least right here, there's 0 error, it appears. Or at least I need to wait for the initial propagation before I start propagating the errors. So let me see, how many frames does this need? At 12 divided by 60. .53. It's like 550 just to be safe. So we get that forward propagation. Now the backward propagation starts. Alright, so now I need to train with the back propagation somehow. And I need to make sure that this is correct. Yeah, I think this might be the same. Now that I'm looking at it, let me think about this still. Think about this. So offset is -1 is x. So that's going -1 up, backwards, but then when it's going forwards, -1 like that, it's going like that, yeah, it would be the opposite one. Okay, so I had it right before. Alright, so now I need to train. I to v n dot w dot y. Weight train plus forward propagation. I'm supposed to multiply this by its input, aren't I? So instead of adding these, I'm going to do the adding in the shader. Store it in temporary state variable. And we'll do plus equals temporary state times the weight. And I'm also going to do weight value plus equals riv equals I to v n dot w dot y times training rate wv plus equals deriv times weight value, or actually times the input. All right. Oh no, it's already training. What the heck is going on? Ooh, that's pretty noisy. So what's happening here that's already training? Dot x plus equal temporary state times derivative. Probably a very small training value. Now it's got a very small training rate. And that's delayed states. So it's actually not training properly. And it can't train properly unless I somehow have some extended memory. Is there a way I could do... I want to find some way to do like Hebbian learning. Hebbian learning. Synapse between two neurons is strengthened when the neurons on either side of the synapse have highly correlated outputs. Time spiking dependency is like so goddamn hard to do though. Suggested that an individual performs an action, the individual will see, hear, and feel himself perform the action. These reaffirmant sensory signals will trigger activity in neurons responding to the sight sound. Because the activity of these sensory neurons will consistently overlap in time with those of the motor neurons that cause the action, Hebbian learning would predict that the synapses connecting the neurons should be potentiated. So that's the key thing. I somehow need to have it so that when the input of one of these is correlated with the output, see, it doesn't really explain learning though. The spike timing dependent plasticity is the really difficult part. If you're using a neural net, how you're using it. No, actually, I got finished doing the ray tracer. This is the ray tracer. I'm just doing a little playing around now. Oh yeah, the source is up on Shadertoy too now, if you're interested in that. It's a pretty good ray tracer if I say so myself. I love these cloud volumetrics. It's noisy, but if you wait a little bit, it actually looks like a cloud or smoke. Yeah, I'm pretty happy with it. And it's in a nice template to just go and make other ray tracing shaders, because it has a whole material system. And it already has it has like ray marking macros here, so that you can just write the distance function and it'll automatically ray mark it for you. Good stuff. But now there's, yeah, basically really interested in neural network learning. I've already done backpropagation. I've experimented with everything, Adagrad, Atom, RMS prop, but I'm really interested in Hebbian learning or Hebbian learning because it seems like it would work really well for GPU neural nets like this. The issue with backpropagation is you need to build up a memory of all the last states. And if you're just trying to run it as like a field like this, storing those states would basically be turning this field into a volume, which would be so much slower, so much more consume so much more memory. This is what I'm looking for here though. From the point of view of artificial neurons and artificial neural networks, Hebb's principle can be described as a method of determining how to alter the weights between model neurons. The weight between two neurons increases if the two neurons activate simultaneously and reduces if they activate separately. Nodes that tend to be either positive or both negative at the same time have strong positive weights, while those tend to be opposites, following the formulaic description. Literally just multiplying by each other. which is stupidly simple. Yeah, so a Hopfield network is based on Hebbian learning, I believe. Let me just make sure about that. This might be similar to what I'm trying to implement. Guaranteed to converge to a local minimum. This is the type of thing that I'm looking for. Maybe I want to implement a Hopfield network. Training a Hopfield network involves lowering the energy states the net should remember. This allows the net to serve as a content addressable memory system. That is to say, the network will converge to a remembered state if it is given only part of the state. So it's a recurrent neural network. Binary threshold units. The units only take on two different values for their states, and the values determined by whether or not the unit's input exceeded their threshold. Hopfield nets normally have units that take on the value of 1 or -1, and this convention will be used throughout this article. Every pair of units, I and j, in a Hopfield network has a connection that is described by the connectivity weight. Since the Hopfield network can be formally described as a complete undirected graph, no unit has a connection to itself. Constraint that weights are symmetric guarantees that the energy function decreases monotonically while following the activation rules. God damn it, this is complicated. I'm going to actually need to take time to think about this, because the whole thing of symmetric neural networks, where when one of these weights decreases because it's symmetric, it affects one of the other neurons as well. That's crazy. Updating one unit in the Hopfield network is performed using the following rule, where W is the strength of the connection, Sj is the state of unit J, threshold of unit I. So if bigger than threshold +1, form synchronous. Neurons attract or repel each other in state space. Oh, that's awesome. The weight between two units has powerful... This is what I'm talking about being symmetric and affecting each other. The weight between two units has a powerful impact upon the values of the neurons. Consider the connection weight, Wij between two neurons. If Wij bigger than 0, the updating rule implies that when Sj equals 1, the contribution of j in the weighted sum is positive. Thus, Si is pulled by j towards its value. It's negative is pushed by j towards its value -1. Thus, the values of neurons I and j will converge if the weight between them is positive. Similarly, they will diverge if the weight is negative. It either decreases or stays the same upon networking. It's being updated furthermore under repeatedly on... Really interesting. C Hopfield network. Let's see if there's some simple code. Basic Hopfield network for pattern recognition and bit patterns. Use Hebbian rule. Awesome. This is what I'm looking for. So I'm going to save this. I'm probably just going to do this on another stream. I was actually just planning to do like a short 30-minute, 1-hour stream here, but I kind of got distracted on some other stuff. But yeah, I stream... Well, I haven't been streaming for the past week because I've had family, but I should be streaming basically every day now. If you're interested in any of this stuff, ray tracing, graphics programming, neural nets, engine development, I do a lot of this stuff, and it's summer, so I'm doing tons of programming. I have a pretty active programming channel in the Discord. If you want to talk about that stuff, you can join the Discord. But yeah, that was this stream. Follow if you want to check out any of the next streams. I will probably be streaming later today. So yeah, goodbye everyone. Thanks for watching. That's the wrong OBS scene. OBS grabbed the wrong window. God damn it. Thanks for watching. Everyone have a good day.